CVPR.
But like all AI conference nowadays, I think it's more of a legacy reason, the name of computer vision. Of course, most of the paper will be related to computer vision, but nowadays, I would say like the taxonomy that we had in AI back in the days, like computer vision scientist, NLP scientist, that really doesn't hold anymore.
It's multimodal of the same thing.
It's almost anachronistic nowadays if you say, I'm a computer vision expert. I mean, of course you are, but I think nowadays you don't even have a deep understanding of computer vision itself if you are not truly multimodal, meaning that you have a really solid understanding all across the board.
Yeah. I'm going to have a question added to this list later about latent space reasoning, but I'll do that later. Okay.
It's a pixel story.
Yeah, pixel-ish. Okay.
Yeah.
But in any case, okay, cool. So you submitted 1 or 2 papers, you said?
We submitted 2 works.
2 papers?
2 papers, yeah.
Cool. And you will know later this month if you're accepted, or?
Well, not the real acceptance. It's going to be just an initial reviews, but usually they're quite telling. Like you can smell it if you're going in or not most of the time.
Yeah.
And then we're going to have our rebuttal.
Have you done any reviewing yourself of?
Not so much because I try to dodge it as much as possible. It takes
boring.
so much time. But
I've done a number of them for ICLR and whatnot, but it's a lot of work.
It's a lot of work, but I think it's such an important work also to do it properly.
It's part of your duties, so to speak.
Yeah, I would say so. It's part of your responsibilities.
And what was the angles of the papers? Can you give us a hint?
So both of them navigates through this topic of that I would say is the main research topic that I always worked on, most of it. It's domain adaptation. So domain adaptation effectively means it's kind of the problem that curses AI, I would say. Most of it's the major one. I think it's the major problem of AI that what distinguishes, like for example, any human, any creature, like living being to an AI, that we are not static. We learn, we adapt to the situation. Like we evolved to follow this pattern, the survival of the fittest, effectively.
And when you say adaptation, some people, at least me, differentiate between learning and adaptation.
Yeah.
Learning meaning something that actually changed the parameters of the model. Is that what you mean now, that adaptation is something that does not necessarily change the parameters, or? Well,
of course, adaptation does change the parameters of them. Of course, I want to keep it as a very open term right now, because originally it is literally changing the parameter of the model. Yeah. But now there is much more going on, because right now a model, they don't exist, they don't take a form only during training, but we know that now a lot of what a model can do is also happening during the inference. So there's kind of a leakage of the capability of the model from the training phase to the inference phase, right? Yeah. Think about chain of thought or diffusion. Like actually,
are you moving towards more? I'm going to fish now for the topics of these papers, even though you can't speak about them. But just say stuff if you don't.
I can say about the topics. Are you okay? Oh, please.
I can talk. I can
go into it.
So I will say, okay, I will put it a bit in a context first. So one of them both of them tackled a multimodal approach to domain adaptation. Yeah. So we don't focus specifically on computer vision problems. We focus on problems which are a mixture between computer vision and language, meaning that, I would say, semantic understanding of a scene, meaning that, okay, I see something and I need to understand what each object is, but I'm not constraining myself to a fixed set.
Is it some kind of robotic application then? Or?
Well, it could be applied to everything, right? Okay. It could be applied to autonomous driving, to robotics, but anything that involves an understanding of an image and then giving an interpretation of this image.
And even a moving image, or as you move around?
Well, we tackle just a single image within this, but of course, if you have a sequence of images, then
that's the next level of the same problem.
Yeah, I guess. Yeah, I mean, of course, that complicates things, right? Because you have one more dimension. So it's an image, you can see it in 2 or 3 dimensions, depends on if you see the colors as a 3rd dimension. But then you go in 4D effectively. If you have, it doesn't change. Of course, it makes the problem more complicated, but at the same time, it doesn't intrinsically transform. And so,
does it move more in online learning kind of thing? Or
yes, exactly. That's what we do. So the idea is that. So I'm gonna go now in one of the 2 work that we do, and then in this work we actually want to model adaptation as giving a model effectively a library of let's say specialized small models. So when the model get an image from the environment, then we introduce an observer module that see this image and then try to understand, okay, what this image is about, and try to understand a semantic meaning of this image. Then goes into the library that we filled with smaller models, and then it picks which of these models are relevant for.
So it's a kind of mixture of expert, but in a more deliberate sense?
Yeah, you can also see it if you want as a RAG for vision. That can also be another way of seeing it.
Right.
Yeah, with the difference that you don't pick context, like text to put in your context window, but you take parameters. Then you take these parameters, and then you don't take one single model, right? But you can take a number of them and then fuse them.
Very interesting.
So it's like the inspiration of it is very simple. Just imagine that because the thing is this one, no matter how big is your library, let's say that you have 1,000 model in this library, no matter how many domain, and every book of this library could represent a data domain. So imagine that this model is deployed in an autonomous car. Then you see snow, right? And then maybe you've never seen snow before. So what happens is that you will go, you will take this image with snow, then you give it to this observer module. This observer will go into the library and look for which of the many books that you have in this library is about snow. So
it's a more advanced vector search. Instead of just comparing the vector, you actually have some more AI model to do that.
Yeah. So I mean, it's effectively a vector search because we use a model called CLIP.
Of course,
okay.
Yeah.
So it's a multimodal. It's called contrastive learning.
I forgot this as well. But.
Yeah. But anyway, it's a paper from OpenAI published in 2021. And effectively it allows to convert, it's amazing because it projects both images and text in the same latent space.
Yeah.
So if you have an image and if you have text, you project in the same latent space, and then they will be close together if they have the same semantic meaning.
So you can really then merge semantics, vision, and text.
Exactly.
That's
kind of
that's
what
a clip.
It was transformative. I think it's very. I mean, it's a huge popular.
But it's one of the starting points for multimodal.
But actually, I think it's one of the most commercially interesting models as well, because it makes search so more advanced and useful, and actually super simple to use.
But me from the outside, can we say that we want to do multimodal, but isn't CLIP like a pivotal moment in the multimodal?
I see it as
one of them
as a pivotal moment. Yes, yeah. I think that there's not been so much fuss about it in the news, because of course it's not something that
it's too techy.
It's a bit techy, but I think it's been in the field.
Hasn't been represented.
We used it a lot in Deltorian. It was one of the biggest
we use CLIP a lot, but we haven't talked about it as extensively as other.
No, because usually it's kind of a component within. But even in autonomous driving, it's essential. I mean. Just imagine that one of the reasons why, because people, when they talk about autonomous driving, you always think about what is in the car and effectively the algorithm that is running in the car, and you don't think about all the pipeline, what Tesla called the data engine, right? But the data engine, it's effectively that huge and sophisticated pipeline that takes the data from the fleet and then convert it to something usable.
Yeah.
And the problem of autonomous driving, as we know, like.
Now you jump in the gun here.
Right.
Don't go too far now.
I will
stop.
stop.
I mean, super cool, and actually we could continue for a long time.
This was an introduction,
paper.
and we got stuck into your papers, and we can do 1 hour on them.
But best of luck on the papers, and please share it if you got accepted to the conference later. That must be a big thing. Have you been published in CVPR before?
So we published already in equivalent conferences, so in ICCV and ECCV. We published in ICRA, in TDV, so that there have been quite some
cool stuff. Well, with that, we'd love to very much welcome you here. Let's see if I can say the name for once properly, but Pier Luigi Dovesi?
Yeah, that's perfect.
Yes.
Wow.
Nice.
Great job.
First time.
You can do Pierre, I will do Pierre.
They both work.
Well, I mean, as we heard already, you're an AI expert lead, I think it's called, like in Silo, right?
Yeah, right now I think in AMD the official title is senior member of the technical staff, which is very kind of a jargon to say that. I don't know.
Sounds amazing.
No, yeah, I guess the goal is, I don't know, it's, you're an AI expert, that's what it means.
Yeah, you're an AI expert and deep learning and automotive and autonomous driving expert and so many more things. And we have a lot of very, very interesting topics to speak about. But before we go into that, it would be awesome to just hear a little bit more about yourself. Who is really Pier? How would you describe your background?
Oh, wow. Okay. So, I mean, as you said, I'm an AI scientist. That's the only, my definition. I've always been interested in AI. I think I've been very lucky because I was studying in the time where AI was really starting to accelerate into, like, there was the explosion of deep learning. I remember before starting my master, there was this, I watched this video from OpenAI, and they were doing at the time this competition in video games. They released this model playing Dota, which I never played Dota myself. But
what year was this approximately?
2000, I think 17 or something.
17.
And I was absolutely amazed about what it could do. It was like able to beat champions in the game. And being creative in finding solution. And then the same year, or maybe a couple of years before, there were AlphaGo. Yeah. So that's what really inspired me.
When did the first GPT come out? Is it 18, 19? 19 maybe.
Wasn't it? No. GPT-1.
GPT-1.
I think it might be.
No, but you think about ChatGPT, but that was GPT 3.5.
I think it might be the one. If I'm not wrong, might be 18.
I think because 17 and then 18. This is what I was hinting at. It's almost that era, right?
I remember there was the GPT-2, which was already extremely
inspiring.
Inspiring. There was this. Do you remember the story with the
18?
18. Yeah. It makes sense.
While the 2 was probably 19. And there was the story of the unicorns. That was all over the news. They asked the ChatGPT-2 to write. I mean, nowadays it's not news anymore. It's like so boring almost, right? But there was this story of, can you describe, write a news article about researchers finding unicorns? And then the articles was
very
amazing.
Plausible.
Yeah, well, and at that time it was transformative.
How did you consider the progress of GPTs, given the original Transformer and Birch, and then GPT models came about and they started to just accelerate in scale. Were you surprised by the efficiency of just scaling up GPT models
in size?
Well, let me see. Was I surprised? I think there was a time. I think we reached a bit the end of that. Like we milked that field as much as possible. That's why right now maybe like everyone was expecting GPT-5 coming out and amazing transformation of it, and instead we're kind of the field is a bit moving away from just that. It's not just we are realizing that there is a limit of what you can do in just having a prediction model. It's amazing, it's great, it's kind of the engine of it, but then you have to do something more right now.
But I'm a bit older than you, or much older, but before GPTs came about, and before we had the transformers, just scaling up the model and adding more parameters didn't work. I mean, they were completely overfitting the data all the time, and it didn't generalize at all. And suddenly you have a model that you can simply just increase data size and model size, and it just works.
Yeah.
And to me, that was super surprising.
And there's not been much revolution in the architecture ever since. That's what surprises me.
Right.
But this is you said it. If this needed to happen, and we needed to get the knowledge base in that sense filled up. But now, 2025 and onwards, the field we will use that. But now we need to do the other parts to go.
Perhaps we have another pivotal switch. I mean, transformer was a super big thing, of course, and now perhaps we are starting to see not just increasing the size of models and data, but actually changing the architecture for once.
I hope so. It would be interesting to see. Now there are some papers coming out that are extremely promising for that.
Yeah.
Like I think 2 weeks ago there was this paper called Titans, just published transformers with I think an adaptable context window, so to learn, memorize, and forget at test time. That's very exciting. And then there are Transformer Square that I was looking at yesterday, released by Sakana AI. Super cool, Japanese.
Now we're jumping into rabbit holes here directly, but okay. So you get started. You're basically an AI scientist. You got interested in OpenAI's Dota and 2017, etc. And what happened after that?
Yeah, I moved here to Stockholm to study.
In KTH, right?
Yeah. Studied for my master at KTH. It was actually in robotics. Because I come from indeed more an automation engineer background.
Was that Bologna you come from?
Yeah, I studied
Bologna University.
Well, I studied my bachelor both in Bologna and in China. I did a kind of double degree.
Ooh, which one in China? Where in China?
Tongji University in Shanghai.
Oh, so you speak Chinese now?
No,
you wish.
I was speaking a bit in China because that's kind of necessary, but then I forgot everything. That's cool. Sad development for that. But so I came here to study robotics. Then I joined a company here in Stockholm called Univrses, doing autonomous driving. They were doing a bit of consultancy also when I joined. Now they also have a product focusing on smart cities. But I was always in the autonomous driving part.
You were Zenseact at some point as well.
Exactly. So because Zenseact and Univrses are partnering
now.
Yeah. So effectively I was a consultant for Zenseact for a very long time and working there.
So you were from Univrses, a consultant for Zenseact.
Effectively, yes.
Effectively, yeah.
And then you joined Silo at some point.
Then in 2023 joined Silo. And effectively, I'm still there. Silo got acquired this summer by AMD, and now.
If you could just give a super brief introduction to what Silo is, and then I would love to hear the story about when AMD acquired Silo.
Of course.
As well.
So, Silo is or was, let's say, I would say the largest European pure play AI, let's say, service provider. In some sense, so it was a consultancy company with a very academic
hundreds of
mindset.
PhDs in AI, basically.
Yes, actually, it was really an incredible community. It is still an incredible community, doing consultancy and especially focusing a lot in really cutting edge AI projects. So that was really what inspired me of joining them effectively. And
you worked when you were in Silo. What did you mainly work with? And was it?
That was fun because I was working really on every potential aspect of AI. So I joined, and my first project was on Stable Diffusion, and then I worked in application of autonomous driving, but not for cars, for like really huge robots in working mines. Then I worked on LLMs and LLMs on the edge. And then I did, I would say, many other...
Did you count to talk about?
There's so many, but I mean, who doesn't have any launches, right?
All right.
Awesome.
Trying to steal a scope here.
Yes.
I think if we should potentially do a pivot here and start speaking a bit about autonomous driving as well. And
We were almost there. We were almost there in the introduction. So let's go back to that. We are not pivoting. We're going back to.
Okay, returning to the topic then. But perhaps one way to start would be, what do you think about the current challenges? We have known Elon to say that next year we'll have autonomous driving
for
many years, for decades perhaps.
But not just Elon, right? I mean,
no. What do you think the challenges with autonomous driving is?
Well, okay, let me say, there are many, right? I would say, of course, if we have to list them, it could be safety is the number one. It's very obvious.
So it's easy to build like a music recommendation system and put it out there, and
and the second part is like regulations, and that's connected with safety, and and the robustness in some cases. So which is always, they're all connected. I would say safety is encompassing all of them, right? Because if there wasn't an issue with safety, there wouldn't be problem with regulations. And if you had a robust system that could scale to any scenario, every weather condition, every driving style, then you wouldn't have problem with safety. So it's all around this that I see. Then of course you might also go in a more market dynamics, I see. So of course, is it economically sustainable to buy, a Waymo car? I'm not sure about that. Look at the sensor setup. I don't know how much could be each single car for that. And maybe the maintenance that you require. But then this goes not in can we solve autonomous driving, but it goes into the problem, how can we make it
cost efficient, and how can it live as a product and not just as a technology. But could we, maybe if we want to talk about AI and autonomous driving, looking at this from the outside, it seems like there are sort of two different schools of thought. It's the Waymo approach versus the Tesla approach, if I'm simplifying it. Could you just elaborate a little bit about what is Waymo's way of getting to robotaxi, so to speak, and compared to Tesla's view? How would you contrast those two approaches?
I would even say that nowadays it's changing a bit, but I would say they're not even real competitors for that.
Because they're so different.
They're so different in the way that they approach it. Tesla is approaching this in a, they want to start from the product perspective. Like they have already cars on the road and they release FSD on a large scale, which is not so advanced compared to what you might have in Waymo or other deep tech focused players. But then, of course, by doing so, they solve other problems. Like they use, I would say, the power of having a huge fleet deployed on that. That eventually might give a scaling capability that might even overtake.
Overtake, yeah.
Yes. When it comes, and then Waymo instead is doing a totally different businesses, robotaxis, and this is supposed to be like they won't really crack. I see the autonomous driving problem as a thing. So they don't care how much it takes, how many sensors you need. You really need to do it. And of course, they are way more advanced in the capabilities of the cars.
Perhaps we just need to give some background. Tesla, I think everyone knows, but Waymo, it's a Google company, and they are using a lot more sensors like lidars, etc. that Tesla is not yet at least using when driving. And but they have much more expensive approach to do it, right?
And they also, if I understand it right, the Waymo robotaxis right now, they also have a technique of how to map out the certain area where they are deployed.
Well, I think the mapping out happens even beforehand. Yeah. So they rely on this thing called HD maps, which are maps that are not just like the Google map that we all use. They have everything in them. They are
potholes and stuff. Right?
I of course I don't know, but then there is a ridiculous amount of details and a ridiculous amount of updates.
But this is a huge distinction, right? That one relies on the HD map and one.
I think everyone relies on HD maps in some regard, but of course Waymo is releasing is having these autonomous fleets only in very selected scenarios, and I suppose they do a very careful mapping of every city before its release. And hopefully they will, I think, relax this constraint slowly. And this also, I would say, the thing is, like, you need this such a powerful, I would say, the intelligence of the car and the sensor setup are something that you can actually, in some sense, sum together to reach a certain threshold. The more some companies are investing right now so much in having a much deeper and capable intelligence layer, so to say, and contextual understanding. And if you have it such a high level, then you don't need maybe at the same time, you challenge yourself in not needing so much sensor stuff. If you have way more sensors, then effectively you do it because you know that you don't have enough contextual understanding. So you will need to have raw information.
So having more sensor relaxes the performance needs for other parts.
That's why we're moving. Like if you see, we're actually, like, the amount of sensors is actually going a bit lighter every year. Like if you look at companies such as Mobileye, the Intel one, they decided, okay, we're gonna drop the LiDAR part.
Oh, they did? I didn't know that.
Yeah.
And this is, of course, in order to figure out how can we make this scalable, cost efficiently, and all this.
Yeah.
Or
it's mainly that, of course. And at the same time, I think, I still believe I know this is not very. I'm not anymore in the autonomous driving, so I can speak freely.
So you can have opinions now.
Yeah, I can have opinions, right? So I still think that there is a sense of what the Andrej Karpathy philosophy in saying, okay, a human doesn't need 10 LiDARs on a car and 4 radars and 12 cameras. We can do it in a much easier way. So I think as AI progresses and contextual understanding of AI progresses, then you should be able to not have this need. It's kind of a fairly easy task for a human to drive or to do other tasks in the wild with a limited sensor setup. Right.
And just to give some background as well, Waymo actually have had robotaxis in production for many, many years, right? And in just a few selected cities in the US, but still. And Tesla still do not, but they are claiming to do soon. Yeah. So they have very different go-to-market strategies for this, right?
Vastly different. Yeah. That's why, to me, it is even hard to see them as real competitors. Even though now Tesla wants to move in the robotaxi domain, so then now I might see them. Okay, now maybe, and I think maybe when Tesla is releasing their own robotaxis, then I know that they will have like teleoperators to improve safety, which of course kind of defeat the purpose of the point. But I think that's not the point, right? That's not the point of. It's more like to prove that you can do it and to see to which extent you can do it. And I think Waymo is now extending so much the number of not so much, but extending significantly the number of cities that are supporting. I think before it was just San Francisco and Phoenix, and now they moved to Chicago and maybe
New York as well.
I don't know if New York, because I think they're staying only in the south of the US.
There's no snow. I don't know.
But so given we had Cruise as well before, they had some fatal accidents as well, and they shut down all the robotaxi business. But who do you think will be the long-term winner? Which strategy do you think will, in 5+ years, turn out to have the best approach?
I think there's not going to be a single. I'm going to give you one of these boring answers, right? I know you want. But I think, I think there's not going to be a single winner. I think they're targeting different strategies. There is, of course, Waymo. They have the most advanced capabilities at the moment. Zoox is moving quite well, I think. Tesla, of course, they have
about Chinese like BYD and
they can probably have the advantage of more relaxed regulations, and then that could also be, and probably also cost effective. But I'm not informed about Chinese market that much. And then I think there's kind of also this wild card of I don't know if you know Wave. It's a company in the UK. They raised $1 billion just in 1 year, It's founded by, I love it also because it's founded by a scientist, by Alex Kendall, which when I knew Alex Kendall, I was doing my thesis, I remember, and his papers was kind of the baseline of my own paper. And it was like, okay, so it was a pure scientist. He studied in Cambridge and did a bunch of internships.
It's fun to hear that scientists actually can build companies as well.
Yes, and such a successful scientist. It's really an inspiration. And then he founded Wave, and it's tremendously successful. And their approach is basically, when they say there was this, of course, I was talking with my most senior colleagues in Univrses in particular, and they say like, but Tesla is doing all these end-to-end approaches that are not very safe. And then Wave is doing that like times 10. So they really try to solve this with a pure end-to-end approach.
Okay. We have to go into this topic now. So I was hoping the next topic would be a bit about like the key concepts of autonomous driving. But let me just give some, in my view of it, which probably is wrong, and you can really describe more what you mean with the end-to-end approach with which Wave may be doing. But to my understanding at least, if you take version 12 of FSD in Tesla, the big change there was that normally if you take the three components like perception, control and planning the route, controlling
planning and control.
Planning and control and perception from the sensors. Normally, most companies, including in Sweden, we have Scania, for example, doing self-driving trucks and whatnot, and they just have AI for the perception part, and then they more or less do hard-coded rules for the planning and the control.
That's a very old-style approach.
Yes, but I think Tesla did it as well before version 12.
Yes, everyone had to, because AI wasn't even sophisticated enough to support more of that.
Yeah. Is this what you mean with the end-to-end approach, or how would you describe what Wave is doing?
Yeah, you can imagine the autonomous driving pipeline as a kind of a number of blocks connected one to each other. So you have the perception layer, then you have what was called at some time like the localization and planning at some point. So you first perceive the environment, right? Then what we were doing, it was like, okay, now that I perceive the environment, I need to convert this information in where am I, what is the map, what is the map looking like, and where am I in the map? And okay, now I have a view of what the map looks like and where I'm in the map. And now I'll have to understand, okay, but where do I want to go? And then you have the planning part of it. And then you need to do effectively, when you have the planning, you create a path to reach your objective, and then you control. So you effectively send signals to your actuators. So it could be the motor, the wheels, the steering wheel, and everything.
So the mapping, would the mapping be equivalent of, I think this Tesla using the word vector space for this, so they use this is
but it's after perception. You get from sensor space into vector
sensor space to vector space, right?
It's basically latent space, right?
Yeah.
So the thing is, like, this was I would say the legacy approach, where you have all these components and everything. And so the reason why people liked it was that it's explainable effectively, so you can think.
The storytelling was easy.
The safety approach was also like, it's easier because you can understand, okay, why, if there's something that fails, you know which layer it failed. Okay, I didn't detect the pedestrian, so the problem was in the perception. Or maybe the, loop closure of the SLAM system in the whatever mapping failed. Okay, then that's the problem. Or maybe the control overshooted and then I cannot control oversteer, for example. But then you also degrade the performance of it because you need to rely on a number of heuristics to do it, and the pipeline is all disaggregated, and then information doesn't flow. And simply every time that you try to engineer things with, and you put human knowledge of it, you at some point you realize that you are enforcing your own biases as a human, and then you start, and an AI can do it better. That's a bitter lesson in AI, right?
It's hard to scale if you have to rely on human written rules, right?
Yes, it will fail more or less sooner or later. So what happened is that slowly there was basically effectively the AI leaking from the perception more and more into the pipeline. So the first one to kind of give up was the so you have perception, and then you have all this part of localization and mapping, and now all that part has been effectively merged into the perception, so they are just a unique system, and then you slowly leak into the planning, and then you have one big system going from perception to planning, and now it will go and leak even more into the control part. And that's what it means end-to-end. That basically means image in, and then you have the controls out. So it's like I send the video in, and then the AI will tell me, okay, now you have to turn left or right.
But it's still different models, you think, but they're connected, or do you think it's literally like one and the same model? Or?
So it doesn't happen in one day, this transition, right?
Yeah.
And there are still people, and I mean, there are still experts who think that this is not the right way. So I'm just giving you my view on it. But yeah, it started to happen by having several models, and then you take several models and you train together. And so you can already say it's end-to-end, and then you stop having separate model, but you just have one big model with the output sticking out of it. So can you at least visualize what the AI is thinking regarding the mapping, or what is the AI thinking about the perception? And slowly you will probably start to drop also these.
I remember Elon speaking about this, and I think Carpathy was as well as at some point. But one of the benefits of having this kind of end-to-end approach is that if you train the perception part separately, you basically need to manually annotate, what is a lane, what is a pedestrian, what is a traffic light, etc. And if you actually connect it directly to the control through planning, then perhaps you don't need to annotate as much, at least.
Yeah, the annotation and the data problem are insane in AI. Because one can think that the problem is the data, that we don't have enough data, which is true. But just consider that you can usually afford to annotate less than maybe 0.1% of your whole data set, because the annotation are so expensive, and even you annotate a lot. But then you just imagine if you have a fleet of cars, they collect hours and hours of images every day, and not just images, you have every possible sensor mounted on them. So you have this huge flow of data, and you just have to pick the tip of the iceberg, and then you can annotate that. With huge problems, because every time that you have an annotation, you're basically saying this part of the image, of the input, I care about, and everything else, I discard it, right? Because if I annotate, let's say, a pedestrian, then I'm saying that maybe many other information around, I don't really care. So you lose some. Annotating also requires losing information effectively. And that's of course not a really sustainable approach. So everyone now is moving towards having data engines. So system that can complement the annotation process using data that you don't annotate, so you can either pseudo-annotate them, or maybe even better, you use them as they are. You really learn from the raw data. You have this unsupervised learning approaches.
So you think Elon is correct, more or less, that their system now can learn how to drive without having humans annotating what a lane is, or a traffic light is, or a pedestrian is, or a car is, or...
I think maybe unfortunately that you still need a bit of annotation.
Yeah. To bootstrap it in some way, right? I mean, how
or to test, to even provide some safety guarantees. That's something that you cannot really escape. But I really think that they will remain this very tiny bit of the equation, and you will have way more data that are absolutely non-annotated. You will have some data that you might want to pseudo-annotate, and then you will have a lot of synthetic data as well.
Awesome. And if we just continue a bit on the autonomous driving part before, you have so many super interesting topics, I think, with Rain.ai and whatnot.
Pick one of the topics.
But let's, we're soon into the new section, I think, as well. So before we go there, perhaps just continuing a bit in the autonomous driving. And if we think more, I mean, one thing that's been discussed, is generative AI or synthetic data, could that have a role, do you think, in autonomous driving in the future?
Yeah, well, definitely. I mean, this is, the answer of this question.
It's a bit leading, but still.
Yeah, but how?
Yeah, okay.
How?
There are, I think, many surprising, when we think about, synthetic data, they don't come, so there's no free lunch, the problem. So of course, synthetic data can help. The problem of autonomous driving is also this one, right? You have, I usually, when I give a presentation about autonomous driving, I always say like, look, right now we have superhuman perception in autonomous driving cars. You can see, and they can perceive and map way better than any human.
And do it around the car, in real time.
Yes.
To a way that no human can ever do.
And LiDAR through fog.
Yeah.
But then this is true until the unexpected happen. And then you say, of course. But then the problem is that the unexpected happen all the time. So you are in a situation where that's what's called the long tail of data, where most of the situations, most of the data are extremely, most of the situations are extremely rare, verging on being unique. So, of course, having synthetic data, which can somehow make more frequent of this, increase the frequency of situations that are extremely rare, could help the AI. Or you can augment real data. This is another thing that is really interesting. Like you take real data and then you modify them to create an unseen situation. Or now there are application of, let's say, for example, Wave developed their own ghost gym, which you can effectively create, start from a video. They also have a system called Gaia. That you can create a video, take a video that really happened, and then modify it and change the ending of it. So what if you have this pedestrian who's walking down the street now is decided to stay still or decide to have a different path? So this is, it's difficult to say, is this real data? Is it synthetic? It's both. And what I was saying, when there is no free lunch, it means that, of course, as you introduce synthetic data, you will also introduce something which is called a domain shift. So you will introduce a bias in your model, because these data coming in, they will have a different distribution compared to the real data, and this is inevitable. Even though, but I cannot see it as human. Sure, you cannot see it, but the AI will see it. Rest assured.
Because you have some model that generates synthetic data that is not real in some sense.
Yes.
Yeah.
And of course, you benefit from the fact that it has perfect annotations because they're synthetic, but then you will pay this in this domain shift. And that's why adaptation, it's so, I would say, it will become, now it's not applied much, I would say, in terms of time, but it will become way more relevant.
But this is sort of even linking back to the relevancy of your paper here, to talk about the domain adaptability.
Yeah.
Because you have now extrapolated, you end up with a problem around the corner that you are now working on.
Yeah, exactly. So
did I get it right?
No, it's perfectly correct. The first problem of adaptation started exactly because of this. You had a synthetic data generator, and then we realized that when you train a model on synthetic data, you release it in the wild. It's terrible. It doesn't work. So people started to say, okay, how can we? So a first approach could be, can we adapt the data? So make the data look more real, and then train. Okay, that works. But then we realize, okay, still not enough. Even if you try to make this data look more real from the simulation, the model will still not behave. So what you need to do now is that you take a model trained, or that is being trained on synthetic data. Then you take real data, and you don't even need most often the labels of the real data, but just by there are many ways of doing it, but just by influencing, let's say it this way, influencing the model with the real data, the aspect of the real data, you effectively transition the knowledge of the model towards performing in the real world. And this is kind of the first part. So how to use synthetic data. The problem is that right now, I think domain adaptation can even help us in another way, that if you enable adaptation to happen online, meaning in the car, then you have a system that could adapt and change in real time. So let's say you see a new weather condition that has never happened before, and then your model will actually rewire itself while driving, adapting to the new driving scenario.
That sounds amazing.
That's super cool.
It's strange. I worked with online learning for like 20 years ago, and then it was no deep learning. It was like traditional machine learning. But then in deep learning, the online learning part has just disappeared. So I am so glad to hear that potentially it would be some kind of rejuvenation, so to speak, of online learning.
And of course, like safety people now will like put their hands in their hair like you're like already because of course it's already kind of problematic to have a system and to prove that it's safe. Imagine if you have a system who rewire itself based on the situation. Like of course the safety is, but then I mean there are many ways. Like one of the approaches we find is that you can actually make this adaptation process very explainable. Then this was indeed our last work. Like if you pick several other models and you merge them together, then you know what is going into your adapted model. You know that you are like taking 20% of let's say let's put it this way. I have a model that has been trained on snow data, like maybe has been trained only on sunny data. Now I deploy it in the snow during the night. And how it does two domain shifts. One is the night, one is the snow. So if I give a library of models, one is sunny snow and the other one is clear night, then I cannot pick only one. But if I could pick 50% of one, 50% on the other, and then inject these two plugin in the model, then I can explain how the adaptation is happening. That maybe for safety people is a bit more digestible.
Cool. Super cool lines of thoughts here.
Awesome. And I think let's go on.
It's time for AI News, brought to you by AIAW Podcast.
So yes, we usually have this kind of middle pause where we take a break from the podcast and the amazing rabbit holes of discussion into autonomous driving and whatnot with Pier here. But now let's take a few minutes to speak about some of the recent news that we've had in the last couple of weeks. And who wants to go first? Should I start perhaps?
You can start.
So I'm a big fan of the JEPA paper from Jan LeCun, for example, and then thinking of latent space reasoning, or at least moving away from just having the traditional type of transformer models and moving more into reasoning. So there was a paper actually by Microsoft and Microsoft Research in Asia. It's called R-Star Math, and they try to get really good in reasoning and math by having a super small model. It's just 7 billion parameters, and it's nothing near to if we think that O1 or GPT-4o had 1.7 trillion parameters in it. This is like hundreds of it. So a small model more or less, but actually beating the performance of O1. And this was really interesting, I think. And how they actually did that was they actually used Qwen, the Chinese open source model, and it was pre-trained then for normal kind of language model capabilities. But then they actually trained it by syntactic data approach. So they basically generate in Monte Carlo search kind of a way to come up with an answer for math problems. And one way that I've been speaking in the past, what I hope and believe these kind of AGI models will move towards is thinking about AlphaGo, for example, or AlphaZero in the past, where you have human data that is like how you play the game of Go, but AlphaGo also had syntactic data, and actually having this combination of the two made it surpass the performance of humans. Now, I think we can see here how they could actually use mainly synthetic data from a pre-trained model, but they actually, from scratch, more or less, generate their own data in how to solve these kind of math problems, and then use a mix of supervised fine-tuning and reinforcement learning to build the model in a number of steps, and then having a model that is significantly smaller but still so much better in reasoning. So I think this is so exciting, because I think it's not really good for society if we just keep increasing the size of these models, but actually finding these kind of small models that actually outperform for specific tasks like reasoning And math in this case is very exciting. So the way they did it in some sense is that they use basically chain of thought, where you try to ask the model to explain a number of steps going forward, but they also made it produce code, Python code, meanwhile. So by having this kind of Python code combined with the chain of thought steps, they could verify what works or not. And in that way, they can actually quickly then build up, these are a proper path forward that will lead to the correct math answer in the end, and these one will not. And then they had what they call SLMs, so small language model instead of a large language model. So they had 2 SLMs, small language models. One for the policy, which basically is, I have a background in reinforcement learning, so I can go very deep here, but I shouldn't. But they have one model for the policy, which basically is what step to take, what action to take. Mm-hmm. And then they call it a PRM, I think, the policy reward model. It's basically a value model saying what is the value of going to this step. So some kind of proxy of what the reward would be if they actually go forward in this step. And they train these 2 SLMs, small models, language models, to be able to just traverse the possible space. And then they use Monte Carlo tree search, similar to AlphaGo. It's actually very similar to AlphaGo and AlphaZero, being able to just go through the search space by both, doing exploitation of the current policy, but also exploration. I think it's very similar to what AlphaGo does. It moves into the language model space and reduces the size of the model, improves performance significantly. I think they had an example of, they take the small 7B Quen model, which is the Chinese model from Alibaba, I think, and without having fine-tuned it basically had like 58% on one of the tests, and it went to 90% accuracy.
Wow.
And they also took Microsoft's Phi 3, this is micro research, so they took that, and it moved from 41 to 86% accuracy.
All right.
This is, of course, I think the future, and I think it has a lot of connections to also JEPA in some sense, moving to having this kind of multi-step reasoning. I don't like the test time compute term, so I'm trying to avoid that. But it has these kind of multi-step kind of reasoning steps also while training, which I think 01 and 03 has. And then also being able to move in, it's not really latent space, but there's a step they take is not per token anymore. It's actually a whole chain of thought step. So it's moving beyond token autoregressive kind of thinking, which is also what Jan LeCun, would like to do. Anyway, I can speak much more about this, but I think it's a super exciting time, and I think also this means that we can start to see some kind of internals of probably how 01 and 03 works without them having released the details of it, because they have been able to surpass or at least catch up to the performance of 01 with this much smaller model that they probably have.
Yeah. But I mean, this is, it's very, I would say it's very inspiring to see how the model size is not just all it matters, right? Yeah. Because it's what they talk about system 1 and system 2 thinking, yes. Right? That, of course, a bigger model can, and I think that we can say that they have knowledge. I mean, of course, it's just an X token prediction, but in order to solve this simple task, of course, they had to store so much knowledge in it. But then there are still some problems that inherently we realize that they cannot be solved just by going system 1 thinking, just purely predicting, and you need reasoning. Of course, this changes a lot in the whole. I think it's the same. That's what I also say, that this taxonomy of AI, computer vision, and NLP are falling apart, because it's the same that we saw in image generation, not just in text generation, right? 4, 5, 3, even 3 years ago, we were using guns to generate images. Yeah. When you were generating the image just in one shot. Yeah. Right now, instead, we have progressing refinement, right, with the diffusion model. And a chain of thought is nothing else than an rudimental diffusion model.
It's a multi-step kind of process, right?
It's just the same thing. You don't, let's say if you need to write a book with the chain of thought, you first write the chapters, titles, just the content, then you provide maybe an abstract for each chapter, and then you expand on it, and then it's literally what's happening when you have diffusion.
Yeah, yeah, well said.
Interesting.
And it's just moving like from the training domain to having more in the inference phase. So basically now you need to see them together. And of course, the more you expand one, the more you can shrink the other if you want.
Exactly. It's like two orthogonal kind of dimensions. One is simply you increase the parameter size of a model.
Yeah.
You can get some performance, or you increase the reasoning steps.
Yeah.
And having a good way to do that, and then you can decrease instead the parameter size.
And you can say that the performance is somewhat the area that you describe by navigating in each dimension.
Yeah. Cool. I think it's super cool.
So let me go in between, because I will be the least nerdy of these news, I think. I want to highlight. I did as a preparation a little bit deeper revisit and looked at Mark Zuckerberg's interview podcast with Joe Rogan. And what's led me down that path is that there was several different news pieces that went quite viral on LinkedIn, and different things that has been said. So there are three pieces here. The first one was like all the news outcry. We will take away the fact checkers, and we will use open notes. And it's been a very politicized discussion. And I urge anyone who wants to have it from the horse's mouth, please have a listen carefully to how Mark is describing it. That's number one. Number two was to hear his prediction on user interface. You know, how we have computers. Should we really be living in the physical world and then switching to our screens? That's another interesting take to hear from him. And then the third one was a quite large debate where someone used, Mark is saying he will replace he will replace his mid-junior engineers. So with these three things in mind, I went in and tried to form my own opinion. What did he really say? If I take the first one, what everybody needs to understand that with the amounts of data that we are dealing with, billions of topics. Number one, what the fact checkers is looking at is 0%. So they're not really doing a good job. This is number one. Number two, what the fact checkers are actually looking at and working on is a very specific topics in relation to politics and stuff like that. So when it comes to the hardcore stuff like terrorist stuff, drug stuff, illegal stuff, there are many other approaches that they are doing, and they are not stopping them at all. It's not changing. So it's the fundamentals of how to deal with this political stuff. So it's a little bit like you take one small thing and you politicize that, and you make a discussion and debate about that, which blows the whole thing out of proportion in terms of what it is and if it really works. And the most interesting thing what Mark did was to highlight the real problem is, how you understand the confidence level. Do you want it to be 80%, 90% accurate all the time? Then you're gonna shut down innocent people. Is that what you want, or you want to go the other way around? And I never want to shut down an innocent person, and therefore, you will leak the real terrorist stuff. So this whole balancing act is super hard. So it was quite interesting to actually hear a really deep debate on how Meta in 8 to 10 years has iterated on these ideas. And so this it's so the way we get this snippet and the political outcries, go to the source and listen to it. That was number one. The AI story. It was a huge viral topic on LinkedIn, and I was participating. People were saying, I was basically saying, don't use AI will replace engineers rhetoric. I think it's a very dangerous rhetoric. First of all, if you're not super experts, you understand that what we are talking about is a reinvention of an engineering department. It's the fundamental workflow in engineering changes. And that leads to the path where you can have less engineers doing the same work, but it's not as simple as you have an old process and you take one guy out and you put an AI in. And then when you listen carefully, which is to Mark, he's using the word augmenting. We're going to augment our engineering process. But he says it quite quickly, and then they are talking about the implications and consequences. So here's the core story. What works as a discussion on geopolitical or macro perspective versus what is actually happening in reality when you're changing something and you bring in AI into engineering or coding in this case. And where Mark himself, so this is also very easy to miss what he's saying. And which then had a huge debate and, we will replace 80%, blah, blah, blah.
But I mean, who isn't, right? Like, who isn't using AI already to enhance engineering? Like, I mean, I think the major, most of the benefits of AI was also in code, helping, making code faster, so helping the engineer. So it's not. It's hardly news.
If I'm going to be cynical, this is a non-issue. Yeah. So what ultimately Mark is saying is that if you're not on the productivity frontier of the tools you should be using as a software engineer, you're toast. Wasn't that relevant 5 years ago, 10 years ago? So if you haven't followed the techniques all the way through, don't you need to follow the techniques?
Well, just to have it to write code, of course, is a big augmentation that we're seeing, and just seeing the decline of Stack Overflow, and when you just ask ChatGPT not only to help you write, but also to understand and fix problems is immense, of course. But I think another point is really, we'd had Anton Osika here as well, speaking about the GPT engineer and Lovable, and that can do more than just augment the engineer in some potential way. You can simply prompt it to write a whole application and change an application, and that's another level, I would say. So that could be a future, but still, I would say the human is still there.
I think so too, and I think the core topic is that we need to have one type of rhetoric when we look at the macroeconomic effects, that less engineers is needed to do much more work. This is true, but how many engineers do we need? There is a paradox in here that when we grow in maturity of something, that our consumption demands just explodes, and we want more software, and all of a sudden, well, what's the net effect? Who knows?
I mean, it's not that we don't need to write code. We need to write much more code than we currently can.
Way more.
So it's simply that we can do so much more.
But I think it's lost. I was pushing hard on LinkedIn, and I got pushback on it. This is not replacing engineers. This is augmenting engineering operations at the fundamental core, how it's done, right? But it means we need engineers in order to cope with that new socio-technical context. Yeah. So, I mean, I stopped there, but the last one was really interesting also to hear. He basically thinks we're going to live in a world where the physical vision and the artificial vision, computer screen is overlaid. So we go into glasses, we're going to go to contact lens interfaces. So he doesn't really believe in the switching.
He's been trying that for 10 years.
A bit of fixation with his metaverse, which has been proven quite unsuccessful.
This is not metaverse. This is not VR. This is AR. He was
but that is the similar thing. He's trying to rebrand it a bit.
He's going from VR to AR.
I don't know. I have a huge, let's put it this way, I have a huge respect for Meta AI. I think they're doing great.
Yes.
Then Mark is Mark, and I don't know, everyone has its own opinion.
It's fun to see, when Mark, pushed for AR, for, I don't know, 5 years ago, and the company was just going down in market cap, and then they switched to, now we're going to focus on AI, and it just exploded in value. And now it's, he's becoming one of the richest men in the world suddenly again, because they actually focused on AI instead of AR, and of course.
The interesting thing is how we have been predicting that here, and you being a little bit of a Jan LeCun fanboy.
Yes,
we were like, and finally Jan LeCun got his seat at the table, so to speak. The stuff they were doing was awesome all the time.
I'm curious what Jan LeCun, how he will react to this change of art, which. Of Mark that he had recently. To be honest.
Which one was that? Proprietary, open source, or which one?
No, I mean, of course. I think the Meta AI has distinguished itself thanks to a lot of publication really important publication that they read recently.
Openly, yeah.
And also their stance on open source, which of course it's also a commercial mover. Clearly, they don't do it for the benefit of humanity. They do it because it helps them to provide industry standards. And they position themselves in owning effectively these industry standards. But at the same time, there is a part which is for the benefit of society having open source AI. I think I strongly believe so. I don't believe when they say.
Okay, I'll add this as a topic. I'd love to hear more
about. It's a huge topic we have discussed a lot. And I love someone who's initiated and have opinions about that.
But I don't think Jellikun will be comfortable maybe with this new.
So could you give it to us in a nutshell?
I think, for one, Mark Zuckerberg and Elon Musk were enemies in the past, and now it seems like Mark is at least slightly moving towards Elon.
Yeah,
but
how surprising, right? Definitely not interest move. Right?
No, but then Jan LeCun was also in a big clinch. With Elon Musk. They had these kind of big fights on Twitter, and they were calling each other for whatever kind of horrible name. Doing
what is research, or you need to be published.
So I don't think I agree with you. I don't think Jan LeCun is very happy with this move, but we'll see. It will be super exciting future, I think, to see what happens there. It's a cool company with Meta.
Anyway, but for me it was a little bit like sometimes you can go and watch the 2 hours and then you get a little bit different feeling for topics than what was sort of in the news flashes on the social media.
Pier, do you have anything you want to bring up? Some interesting news or something?
No, I don't have so much. I mean, you covered so much already. I feel like not so much is left.
Goran, anything from you?
I have actually one. And I don't know about this, but if you know about this, but 3 days ago actually, the Biden-Harris administration released something which is called interim final rule on AI diffusion, which is basically just a cheap export control measure. So now the United States is basically has this measure when they are, to my perspective, actually policing which countries and which companies can have access to chips or not.
Exactly.
Which means that they are controlling the entire game of AI, which is super for them because I understand why they are doing it. They are doing it for security measures, economic strength, and etc. But this also gives us to a technical balkanization of the world, if I can use that term.
I like that.
Right? Or as we are calling it, AI divide. In this measure, basically, how it's placed is that there are 18 allied countries, and I believe probably the list has not been released, but Sweden probably is one of them.
In that, so I saw that.
Yeah, so they don't need to apply for that. The chip orders that are around 1,700 GPUs are not also basically concerned with this measure. But then you have, for example, entities that have headquarters in some of these allied countries. They are limited to how many chips they can actually use. I think it was around, I will not speculate actually about this, but there was some kind of a number. And then you have, so basically even in Europe now, we are divided just because somebody decided that this is going to be the case. So you have like European countries that are part of this 18 that can actually get like a bigger chipset import, and some of them not. Also, they limit, so you can think like, oh, but the European Union is like all together and there is a governmental to governmental policies and agreements and etc. Well, they also thought about that. So there is like a restriction actually on almost everything. And of course, why I'm pissed about this is because it's affecting the AI stock market quite a lot. And I reinvested in Nvidia, and now they're shitting on my stocks.
And Jensen was furious.
Yeah, I mean, it didn't fall that much, but you can see that actually right now it's becoming the chipset war is actually starting. Before it was the AI divide, now it's a chip divide.
We already talked about that a little bit last year in the final, but now this was the next piece of the escalation of the chip war.
But I mean, it's moving into an area which I don't want to go into, but of course it has a lot of geopolitics of
Yes,
AI
yes,
that
yes,
will
yes,
just
yes.
increase
Yeah.
more and more coming years, of course, because of the impact of AI and also the impact to national security, which I think they are partly mentioning here. And that's
Another interesting thought is that basically now United States is putting it themselves as we own AI. We decide what AI is. We decide how many chips you're gonna get. Although all the manufacturing, units, the machines that are building these chips that are actually done in Europe, in Netherlands, but it doesn't. You have it
it's
in
the
Taiwan as well,
original.
and etc. Right? But it's just a little bit annoying. Kudos to all of this, but I just don't see how this is going to
But
boost innovation
I saw
across.
one number. Of course, China is on the other side of who's on it, and we still need to understand. If I take the NVIDIA perspective, I heard a number, I read a number, as much as 40% of the GPUs that NVIDIA sells, 40% goes to Chinese type, which is logical.
I doubt that.
No, but why? Because if they're using NVIDIA chips in the big large language models in China, of course.
yeah.
There was articles about old models of machines that basically these chipsets are made, and it's not exactly true.
There's been export restrictions for
a long time.
NVIDIA chip to China for a long time, but there are ways to get around it. So
Yes.
there, no, enough said. I think.
We talk about this later. I think this is super interesting, actually.
And imagine what will happen now with Trump. I'm really interested to see what he will do to it and how that will compare to what Biden has done. So that
Yes.
will be.
By the
I
way,
can imagine, but I don't. Yeah.
I saw the entire what is called interview with Zuckerberg. We're gonna talk about that later as well. I thought there was a lot of nonsense in that as well. But let's continue.
Yeah. Awesome. Pierre, I'd love to get more into your very interesting work with the Good AI Lab. But before we go there, I saw you mention something about Rain AI, and it's also a passion interest of mine. So I don't know where your stake or thoughts about this is, but please elaborate a bit. What are your thoughts about Rain AI? And
All right. Okay. I think I should give some context around this. So
we have spoken about them before, it's for your knowledge, but okay.
All right. Okay. So I actually didn't know about Rain AI until I've got contact. I don't remember. Like it was early 2024 or late 2023, and by a colleague, actually one of my co-author who talked with a colleague, and they said like, "Hey, look, I looked into Rain AI, and they're using one of your paper in their as a backbone in their
One of your papers.
Yes,
really?
in their work. I mean, and I was like, okay, what's going on about it? And of course, Rain AI, I can provide some context for. I'm not gonna. I mean, I think it's quite popular as a company, but of course, they're still a startup. They work on neuromorphic computing.
Yeah.
Effectively having these chips that they have DCMI, I think it's called. Basically, the computing is happening in memory.
Yep.
And this allows to have online learning and, in this context, online adaptation. So, of course, but one thing is to have the chip that is able to train and online, so in the car, in the robot, in the agent. But at the same time, you need to know how to learn. Like you need to have a loss function, an objective function to optimize. And that is another thing that you miss when you're training online. So our paper that we published in 2023, indeed, quite late 2023, and it was immediately in their website.
In Rain AI.
Yeah, if you go in Rain AI approach, you will find.
That's a big site.
Kudos, man. Kudos.
Thanks. And so we were a bit quite surprised because it was out of just after 3 months. They
found it, yeah.
Yeah, I don't know. And of course we've been shortly in contact with them. I chatted with I don't remember the head of products or the CTO. I don't remember anymore. And they indeed are fan of this work, and we were not expecting it to be used so quickly. Also because, of course, we were aware of it was just an academic work. with many limits in many sense, but I'm happy that they're finding a use of it.
But of course, neuromorphic computing in itself is, I think it's, we talked about that.
It's one of my favorite topics, by the way.
All right,
So,
okay.
so
So yeah, that's why I got to know RNAi.
should we just do a quick recap of
Yeah, let's do a
neuromorphic
recap and then go back to the old school question, or the classic question: should we, if we want to invest in the next generation, is it neuromorphic or quantum?
Quantum. Quantum is what quantum is, small. Okay, anyway, let me just describe a bit my thinking about neuromorphic, and then love to hear your thoughts about this, and if you agree with my thoughts here. For one, I think, an obvious problem with the the models that we have today is the extreme energy consumption that they're having, and even now every major hyperscaler needs to basically buy a nuclear power plant to be able to drive their data centers. So a problem then with the traditional kind of GPUs and machines that we have is that they have separated memory and CPUs. It's a von Neumann architecture that's been around since 1940s-ish. And in a human brain, it's different. So human brain, you actually have neurons that have both a state and computation in place. So computation in memory, so to speak. And this is more or less what neuromorphic computing is trying to do as well. So then not having to send memory between a memory chip and a CPU chip, and instead having the memory in place directly, will significantly reduce the energy consumption. So instead of having transistors that have to flip all the time, to move memory back and forth, back and forth, back and forth, you just have memory there when you need it. And the other problem is that for normal CPUs and GPUs, they are synchronized on some kind of clock, like gigahertz kind of frequencies. And the human brain is much slower. It's like kilohertz. It's like 1 million times slower, but still with more computational power than the biggest GPUs that we have. So the reason is that they then operate separately. So they are not synchronized, they are asynchronized. And then they only require energy if they change the state, if they flip, if they do this kind of spike. So we have spike in neurons in the brain. So the only energy that's required is really when you change the state in a neuron, the memory in a neuron. And if we can move to that, to not have to move memory back and forth, and only require energy when you change the states in a single neuron, of course the energy consumption could drastically reduce. And if we take the energy of a human brain, it's like in 20 watt kind of region. And if you take like a big cluster of H100s that's necessary for O1 or a big large language models, it's in megawatt kind of range. So it's 1 million difference in energy consumption. Yeah. And if we have any chance in the future to not only have hyperscalers making use of AI, we need to find much more energy efficient ways to work with AI. And I think neuromorphic computing is the way to do it.
Yeah, I see. I mean, my take on it is not. I mean, of course, what you were mentioning is true. My take on it is looking into the more adaptation point of view.
The online point.
I do believe that. I mean, when they talk about even AGI, which I think is like such a vague term that is not really. Yeah. It's not. I mean, it doesn't. I mean, as we are approaching it, it makes less and less sense as we see. But still, if you want to go in that direction, you cannot have an AI which is static and is frozen and needs some engineer in SF saying, okay, we are going to release a new version. You need it.
Online learning.
Yeah, you need to adapt. You need to be able to adapt. And then, so if you need to be able to adapt, then it means that you are somewhat embedded, embodied. Sorry, and if you need to be embodied and you need to adapt, then you need architecture and hardware that allows you to do that. And then if it's in memory computing or spiking, then...
And this kind of memory stress that they have.
So do you see the logic that neuromorphic architecture is more suitable for adaptive or online learning? That do you see they complement each other?
Well,
or can you do it equally with the von Neumann architecture?
Well, of course. I mean, we have used classic GPUs to develop our systems, but I would say they definitely need. So if you have this neuromorphic computing, then they definitely need online. I mean, if you want to learn online, you have the problem that you need to have an objective function online.
Yeah.
And most of our system, they don't have an objective function that is available online because maybe you need annotated data.
So it's more like for neuromorphic computing to work, they need online learning.
Yes, of course.
Yes.
They need algorithms that can support online learning. Yeah. So it could be adaptation algorithm, it could be unsupervised learning. It could be anything that can do this learning cycle without any human intervention. And it also has to be, I would say, what we investigate in that paper that they are using, basically it focuses on 3 questions. So what in the network should be adapted? So because most of the time you think, okay, I have to adapt the whole model, but this doesn't make any sense. So a model is made of billions of parameters. Do you really need to adapt all of them? No, maybe you can just adapt. You can, if you could select which part of these parameters into the adaptation, then you can focus on that. Second question that we focused is not what, but is how to adapt. So actually controlling which kind of adaptation they need. And the final question is when to adapt. Because most of the time, I mean, if I'm in an environment that I know very well, I don't need to do adaptation. But then I need some trigger that tells me, okay, now you are in the unknown. And now that you're in the unknown, you need to start adapting. And you need to start adapting for this amount of time, this amount of parameters, and in this specific way.
So interesting when you go deep on this. It used to opens up new problems or new ways, things you need to solve.
Yeah.
Yeah. You could easily have a rabbit hole there as well.
Yeah.
Time is flying away, and I would love to cover a bit about the good AI lab, and then also go a bit more philosophical in the end here.
We're adding then 1 hour, to the podcast.
Of course, you can sleep here.
Pierre, what is the good AI lab?
Yeah, so this is something very new. Even though the people who are working in it, we've been working together for years already, but then we decided to actually get a bit more official and also to expand. So effectively, we are a non-profit organization. We're an independent AI lab, and we're putting together, I would say, scientists, professors, researchers, engineers from, I would say, the AI leading institutions worldwide. And when I say, of course, AI leading institution, I really mean it. I mean that we have people from AMD, from Google, we have people from the University of Toronto, University of Bologna, TU Munich, KTH, ETH, Zurich. We have King, Bontouch even. I mean, there's, of course, a strong presence of Stockholm people.
Yeah, top AI companies and universities in not only in Sweden but also in the world.
Yeah, worldwide. And we come together like for mainly on the 2 foundation pillars. One is academic AI research that we've actually been doing for a while, and the second one instead is on good AI initiatives. So when it comes to the academic part, is effectively a follow-up of what we've been already doing, and it's something that is started.
You're on the picture as well. That's good.
Yeah. You can see the website is right new, and we have.
What's your role? Were you part of creating it or something, or how?
Yeah, I mean it's a collective initiative.
Share of the board.
Yeah, I'm. I mean, right now I'm.
You're sharing it right now.
I'm sharing it right now. Yeah.
Is Hedvig?
Yeah, she's among our advisors, and yeah.
But go back and redo the mission, the reason, and the rationale for the academic pillar. Well, what are you doing with the? Are you trying to get even closer in collaborations, or what are you trying to achieve? What is the academic pillar?
It started from a need. When it comes to the academic, it started from, I would say, a need that we felt that, okay, I mean, doing research in AI is something that, I mean, we think AI is an extremely important topic. It's fun, but it's also important. And having an understanding of it, having a presence when it comes to research is something that it's equally fundamental. We all we are all working in leading companies, but at the same time, of course, when you work in a company and you do research within the company, then there are some ceremonies that you need to follow. Like when it comes to the IP, when it comes to the topics that you will research, and this might not maybe align to their interest of that your current interest. So what we thought, it was like, okay, we want to create a space. Right now, I would say there's also these topics about, is the Good AI Lab more of a space or more of a subject? Like right now, it's more of a space.
Arenas to come together.
Yeah, an arena to come together and do research together. We have students from universities right now working with us. There are some, these 2 works that we submitted are from that group as well. And now we have 2 students that are now officially starting as students for the Good AI Lab.
So the papers that we were talking about in the introduction today, are they submitted from or from Silo or from Good AI Lab, or a combination?
So the Good AI Lab wasn't not yet a thing at that point, but the people working on that paper were already there. And then they work as a collective effort, I would say, of all these partners that I'm describing.
So the paper is coming from people that is not in Silo AI, but actually now part of...
I am in Silo, and of course in the paper, for example, one of them, there's UC Carlgren. He's in Silo. So, but then we also have people from Google, from ETH in those papers. We have people from TU Munich.
So it's already a collaboration around the paper.
Yes, exactly. And then we also thought another concept that was that, okay, AI innovation is important, but then innovation without a strong guiding purpose is hollow. You need to bring, I mean, we are like, by us recognizing the importance of AI, we also recognize the impact that it has. And right now, the impact of AI and the benefit that it's bringing to society are, even though we think that they are, of course, improving our life, it's only improving the life of a very few privileged. And only improving it's somewhat that is floating here at the top of
it's a divide.
society.
It's a divide here also in terms of the objectives we are and how we are spending money in this.
Yeah, correct. And we want AI to actually float, like to kind of flow outwards and downwards, and like don't just be something for the privileged, but actually support and be effective when it can, and like reach the places that have been long been forgotten. And with how we do it is like, we are engineers, we're scientists, we're not ethicists or philosopher. We're not and we're very pragmatic people. And that's why we are starting collaborations with the Humanitarian Aid Association and with other nonprofits active, not in AI, but actually in education or, as I said, humanitarian aid, medical support, for like active uniquely into providing essential services for people in need.
Why do you think this is important? You know, I have an academic background as well. I certainly can feel that the academic value production is going down, especially compared to the big tech companies. Mm-hmm. Is that one of the reasons, or because this is a place where potentially tech companies are, working closely then with academics? Do you think it's necessary for that reason, or what's your thinking about academic research in general in AI?
Yeah, it's kind of, I mean, it's becoming more and more, let's say, it's getting a bit more a unique, like doing now real, like we see, if we look at the main AI advancement that we saw in the past years and all the news that we talk about, they're all from large industry.
Yes.
So what is the understanding what is the role of academia in this age of AI?
Yeah, exactly.
It's actually very difficult, I think. There is still a need. I think it's not about that there is not a need. Of course there is a need, but what is the impact that it can have?
What should we focus on?
Yeah, and the truth being told, we see that there are fewer and fewer breakthroughs coming from pure academia, and it seems that even pure academia can have an impact only when it's partnering with these large companies. And I think that might represent a problem when it comes to the independence of AI development, which is effectively only following the agenda of the AI leaders in the industry. And this, I mean, of course, science can never decide its own purpose, right? Not even if it's academia, because of course your grants and your money are coming from the government or from industry. So science is never free, but it's even less free if it's pure driven by the industry, right? So I'm not against that. I think, there amazing work coming from industry, and I'm a fan of them. But at the same time, I see the societal limit of that.
It would be sad if the only research that we're seeing is coming from industry in some sense. I mean, it's not bad, as you say. I mean, I think we can do a lot of really good stuff for society, even if it's driven from society, from industry. But there should be a place for academia, right? In some ways.
But could I understand now, because this space, for me, it's a little bit like also in the topic that we have people with these ideals that works in industry. Even you work in industry with AMD and Silo, who sees this deterioration in or limitation in objectives that the research is doing. And then we have academia here where you see, where you stay said it, and it's hard to, the truth is that it's less and less breakthroughs coming out of academia when they're working alone. So here then we have a space, we need to create an arena where we can together, take a little bit from the commercial side, push this here, and then in the same way grab and lift the academic papers back up to breakthroughs. Is that a way to describe also this space as a bridge? I don't know.
That could be the part of the ambition, yeah. Also, because we are not, we are when I mean we are an independent AI lab, I really mean it. I mean, like we are joining, there are a lot of people coming from these institutions, but the institution themselves
have no
there's no part. Of course, there is a declaration of like, okay, it's everything is extremely transparent in this, but of course there is not a direct involvement.
Is there any funding or?
No funding.
Okay, so you do it on free time only?
Yes. Exactly. Correct.
So people who want to invest in the ideal of where we're going, brilliant minds, because you have no puppet strings with the funding. It means when you come together, you can decide on where do we want to direct our efforts, and then you've seen one way of doing that is okay. If you want to do AI for all and for good, we can go to humanitarian aid type.
Can we speak about that? How do you guide your research then? What are your ways to choose what to do research on?
Yeah, so the two initiatives, I would say they are quite independent. So when it comes to AI research, we focus on academic AI research, and that's it. And there is no, right now, any constraint on that or guidance on the research based on what is good AI research. When it comes instead good AI initiatives, I would say they are not research at all. So these are solving real problems. So
then it's more engineering.
We are in a very early stage of that, I must say. So while when it comes to the research, we have years of experience. We have people. We have professors. We have experts for that. For the good AI initiative, it's something that we're starting right now. We're talking now with non-profit and humanitarian organization, but I don't expect that to become research. I see more
solving problems.
Solving problems, real problems. It could be about AI education for sure, but then they have real problems. Like now the main contact that I was talking with president of Doctors Without Borders. And she's now in Lebanon, so for a while we cannot. Our collaboration was like, sorry, I don't have time right now. I'm in the hospital literally. Yeah. So and they have very concrete problems. It's not about research, and just the logistics that you have to deal with medical supplies. They present incredible challenges for them, and of course all their fundings is spent purely on medicines and medical supplies. Yeah. So they cannot afford a fancy predictive logistics system. That they have a lot of people. Like you'll be surprised. It's a new word for me.
So then
you'll be surprised how many people they have just for logistics that aren't even doctors. They are just making sure that the doctors receive what they need.
But just to summarize, so on the one hand side you have the research, and this is this is driven by, I would argue, then joint common interest in a certain field or topic, like computer vision, adaptive learning. And then you have where you as an entity that wants to do good decides we want to put our brain towards real world problems that we choose important, like Doctors Without Borders, logistical problem.
For example, we also we're still in talk with them, and then there's also, another project that we're discussing is also regarding impact analysis for educational projects. So when you have every charitable organization that works in a bit of a different way. Some of them are supporting projects that are, let's say, grassrooted. So they start from locals that they send effectively an application to receive funding to do this societal uplifting project, so to say. And for that, it's way more important to understand the impact analysis of this project. So what is the impact, the societal impact of this project? That, maybe 10 more children got an education this year. That's the impact. And that aligns with the reason why they got the funding. But then this involves a huge amount of documentation. It involves scattered documents and difficult metrics to measure and to visualize. And then for that, you also need AI.
It's so impressive, and I hope you feel as proud as I feel of you for doing it. I almost wish I could get involved in myself in some way. It's amazing work, and I think that is such a good thing.
And what an impressive cast.
Yeah, thanks.
Some very impressive names coming together on this. Really cool.
Yeah, I'm really humbled actually for the team.
Awesome. So time is flying away, and we're getting a bit more into philosophical space now. I'm thinking, should we do open source or latent space reasoning or frontier model? Should we start with open source? Just a bit of the future of open source, perhaps.
Yeah, when you have the open source discussion, and then you also have you can combine them, the prediction between the frontier models. What's the position and what's the use of the frontier model? How would that involve versus, for instance, open source with the theory of being the baby model, or so it's some sort of open source in here, but it's also a prediction.
But let me ask a question. Something we have said in the past is that we know Meta, for example, have strong open source initiatives, and they
open weight.
Open source and open weight and open data and whatnot. And the question is, can that prevail? And if we move into like trillion parameter models and models that become closer and closer to AGI, can we really release them as openly as we do? Jan LeCun says so. I actually don't think so. Do you think we'll see a future where even Meta will stop publishing models publicly as they grow?
For Meta, I don't know. Really. But I think the whole narrative that these models are too dangerous to be released in the wild has been debunked multiple times, right? Like, just think when there was ChatGPT 2, and they never released it. They say, these may be too dangerous. Yeah. Now we have models that are maybe even stronger than GPT-4. They are released. And that's not the reason why the world is falling apart, right? There's no evil entities that
And you don't see a point where the model could be strong enough where it's too dangerous to release them?
I think there could be, first of all, models can be dangerous and do a lot of damage even if they're not open source. It's not the open source that create the problem. Why would we think that a model kept private? Why do we trust that a corporation could be more reliable than
But you want to use it for warfare,
But they are using
but not OpenAI, perhaps, though.
I'm not sure, but they are already, and I find it deeply sickening how much AI is used in warfare nowadays, and how little AI is actually using for humanitarian aid. And instead, there is so much AI, so much developed in the production of AI weapons. And that's not AGI, and those are corporations. So you can create a lot of damage, and actually you will create the most damage for society with proprietary model. The not releasing it open source is not
You don't think there is any extra dangers with open sourcing models?
I mean, on a theoretical level, I see what you mean. That maybe, what if any bad entities could? But why? I mean, they can do it. They are already doing it, right? You already have
it's
AI
like a
guiding.
threshold. I mean, it's like U.S. trying to have export restrictions on ships. It's not preventing them to get the ships. They can still do it, but it creates a barrier at least that makes it a bit more difficult.
Yeah, but why do you think that? I mean, because you are assuming now that they use the US is using AI only for.
No.
Yeah. Okay. But then you get it right. So there could be American companies and corporations using AI the most despicable ways.
Yes.
So.
But the point is, if we don't restrict, okay, let's take this analogy then. And I'm just doing it to have a discussion
Of course.
There are pros and cons with each approach, but it's like saying, I have a kid at home. Mm-hmm. The kid is 4 years old, and I have a gun. And either I lock my gun in my safe. It doesn't prevent the kid from getting it. It could potentially, when I forget to lock the safe or something, it could reach the gun. But compared to having the gun on the kitchen table, available all the time for the kid, that doesn't really understand the consequences, it's an easy choice to be closed with access to the gun for the kid.
Well, this would, I mean, this analogy assumes that the big AI corps are a caring parent, and the people are mindless, stupid child. Yeah, okay, but I don't believe in this narrative. That's I would say the point.
If we skip the big like state actors or the super big tech companies, there are a lot of small. Yeah, I don't want to go in this direction, but okay, there are a lot of small people that are like terrorist reasons or whatever. They don't have access to a lot of funding, but they really want to do something bad.
But why would really GPT-4 be what a terrorist would look for? I'm not sure. I mean, we were saying this with GPT-2 that too dangerous to be released. Now we have Llama 3, which is way more powerful than GPT-2. Yeah. I don't see so many terrorists thinking about Llama 3 when they need to act. But at the same time, there are a lot of companies using LLMs to select their next targets for when it comes to weapons and any sort of solution.
So in short, if we were to summarize, you think we could simply continue to open source models and give them away, both data and code and data, and the models and the weights?
I don't think the danger comes from that. I think, and of course, also seeing that the model. I mean, this also opens for a bigger discussion. If you have let's say that you're really this evil intent, and I mean, it's not like having the model will be enough. You need a huge server. You will need a huge team of computer scientists. So, I releasing the weights, not like keeping the weights closed, for justifying for a matter of safety. Doesn't hold, because you are assuming, having a huge server of GPUs, putting it together, having these models that work in this distributed.
The moat is big anyway.
It's so complicated, so you cannot safeguard it.
You don't think the threshold kind of argument makes any sense, that it's just making it harder is worthwhile?
No, I purely believe it's just.
But what I get out of here most listening is that Pierre is pointing and using a word here, narrative. And what we are experiencing right now, whether we believe it or not, we buy into it now, is that we are being, I would argue, groomed into different types of narratives here. And I remember we had a friend here on the podcast. We talked even about AI apartheid, the importance of open source to Africa and what happens. Yeah. We talked about the tech giants to Europe. And don't forget about the AI or tech apartment ICA is doing to the farmers when they say they need 5G even to be part of the cold chain, right? Mm-hmm. So what we're talking about here is that we need to look at the whole world, and for this argument open source. I mean, like, so it becomes this huge topic of pros and cons that is quite complex if you go from tech giants to terrorists, to, living to Europe, and then all the way to we want an inclusive society. But what we hear now, and even I to a point, we had this conversation about what we believed in was the trajectory. Will open source win or will frontier model win? And even I been caught up in this narrative. And even I think we have shifted in how we have discussed this as, of course, open source, no brainer. And then in December now, both me and Anders were talking about, maybe we need to have closed frontier models, and then we have baby open source.
I think in this year we'll see Meta not releasing a model open source.
So it's one thing in what we believe in is the right way, is one thing what we are predicting, but I find it very refreshing that we have someone of your caliber and that sort of points to this narrative, because it's very healthy. Are we a part of a narrative? Or
But I also believe that the reason why we have open source right now is not because these companies who are releasing open source are doing it for the benefit of society.
Of course not.
Like
we know this. We understand.
Well, right. Like that's why I think I'm quite confident. Even if Meta will stop releasing open source, someone else will, because that's a market position that you have. That's how you cut the gains and the advantage of the first movers. So clearly, if you're the top in the, like OpenAI or Google, you don't release anymore in open source because you want to protect your position in the market. Meta was lagging a bit behind when it's come to the frontier model. Of course, they want to release everything. They want to become the market standard. So they say, sure, you might have this advantage, but I'm still tailing you. And I'm burning all your advantage because everything. Yeah,
but it's deeper than this, because if you look at OpenAI, the model is the value proposition, is the product, and if you look at Meta, the model is part of an ecosystem where they want to sell other things.
Exactly.
So it's hardcore. We want to have our value streams or value pools, and they need to be fueled by models, but at the same time, for us to win, we want to undermine or we want to cut down the moat of the other ones who has this as a core value pool. So it's interesting because Meta's value pool is different to OpenAI.
I think there actually are reasons not to open source, so I'm still going to stick on that. But I think that will also happen because of regulation, and we already seen that even closed source models is not being released in Europe because of regulation. And to be able to defend an open source release of a big model like this will be even tougher, I think, in the future. So this is also a big part of why I think this will be a direction that we will unfortunately need to go to, I think.
Yeah, and that's possible.
And it's interesting because I was really happy to come back to my open source ideals. And I don't know where I'm on the scale right now. I'm really confused.
Awesome. And who knows the answer? We have to ask ChatGPT.
No. Ask an open source model.
Pierre, there is a lot of stuff happening in AI, and a lot of companies are working towards AGI, and we are seeing some changes finally to also the architecture. What do you think the biggest steps are coming years, 2-3 years, to come closer to something that we potentially can call AGI or artificial superintelligence or whatever we call it? Do you have any predictions, guesses for what we will see?
Well, okay. So
easy question.
Easy question, yes. Let me think. I think we've seen now, like we discussed a lot during today about O3 and how the computation is moving kind of steadily from like leaking into inference time. So it's not just something that stays as it was before, purely train something bigger and better. Also because we're realizing this other thing, that data, like we're finishing data. There's not much more data to extract. They have one internet. And I think that's been mentioned. Ilya
had this story.
Data are
this is the fossil fuel of. Yeah.
I still believe that, but that's my personal opinion, that we can still extract more from this data. So still it's true, it's limited, but I guess you can extract a bit more. So there is a limit of efficiency.
My view on this a bit. I mean, I think potentially LLMs or foundational models in the future will have a similar moment as AlphaZero. So AlphaGo already had a mixture of synthetic data and real data. AlphaZero had 0 human data and only synthetic data, and was better than mixing with the bad quality of human data.
Definitely, yeah.
Do you think that could happen for foundational models as well, that we stop relying on human data in that sense?
What about model collapse then?
Well, I think the limit of that, I mean, you can have, the limit of that is, of course, you need the knowledge, you need human knowledge.
But you can have data from the world, yes, of course.
But augment it with synthetic data, you mean?
No. If you take, okay, good question. So one is, human annotations is out to start with. That's been out for a long time, right? So we can have self-supervised learning, and that works without human annotation. So that's no question, that's out. Then if we take AlphaZero, that means removing human experts showing how to play a game, right? So that's out. That's what we potentially are thinking here as well. Then we can see the R-star math kind of approach, where it actually is generating data by itself completely. It's based on a pre-trained, autoregressive token, model, but still, the reasoning part is actually completely self-generated, synthetic data all the way through. So it started to move, I would say, in this direction, and then we can potentially do the same even for vision. I mean, if we are starting to see it for text, we can see it for vision, for audio. I think potentially that could be even more powerful than having to use sensors to get the data.
Yeah, the main difference that I see with AlphaGo is that in AlphaGo you have one game. Yeah. The objective is very simple. You need to win the game. The rules of the game are not changing. So the problem, you go in the real world, the game, no one is telling you the rules of the game, and it's the dimension of the game are like.
So it's much more difficult in the real world, no question about it. It's much simpler in a game like Go or
chess. And then there is other need that the AI to be useful, it needs to have real knowledge. So it needs to know things that.
But don't you think you can generate if you take math problems or like the ARC challenge, with the kind of thing, in math problems you can easily take like a problem. I wanted to have this answer, and then do like.
Yeah, because math, you can see math, it exists, I would say, in a space, which is independent to the real world in some sense, right? Yes. So it's then it gets very philosophical, but then.
But even for a car, wouldn't you say that using a physical engine that lets generate the world, and then creating these kind of scenarios where you drive off the cliff or whatnot, and that potentially being more powerful than.
But then you will have the same biases. So when you build the engine, then how can I say? Then first of all, you have two problems. The first one, as we saw, is the domain shift. You train this simulated environment.
But if it gets good enough?
Well, but then if it's good enough, I would say, how do you know that who generated this environment? Developers. So you will learn.
But it's easy to generate like a physical engine. It's much harder to understand how it works afterwards, like going back from that.
But the thing is, like, AI is really smart. It can actually outplay the engine quite easily. Like you can
But it's easy to do a simulation. Okay,
the thing is, like, if we were able to generate a physical engine, a simulated engine that was truly representative of the real world, then we would be living in a simulation, right?
No, I don't. No, actually not. I think it's actually much easier to do a simulation than actually understanding the world. So it's easy to just take the next step and see how the frames would work in a more like vision kind of sense. But from that go backwards and try to define what does it really mean? What is the car? What is the cliff? That's much harder. And I think actually it is rather easy from a humanly crafted like physics engine to do a very, very realistic simulation and then use that. I mean, that's literally what we see in R-star math, I think.
Well,
and in AlphaZero.
I agree with you when it comes to this well-contained problems. But then when you go to things like autonomous driving or releasing, then the amount of work that would be needed in the simulation. It's just
you could just do multicolored trees, or you can just sample in the space. And
I mean,
do
just
a lot of
to give you an idea, that like the new simulation, the new most promising simulation environment, they're not anymore. I would say they're not anymore purely game engine. They are a mixture, an hybrid between real. So take real data, bring it in the simulation, and then take simulation data and bring it to some form of realistic scenario, but there is always this kind of sim to real and real to sim that goes back and forth.
This is like the game engines of Unity or one of the real hardcore underlying.
Yeah, but then now the goal is to take, let's say I take a video that really happened, I bring into the simulation environment that looks like exactly like the real thing, and then I create
something very similar, and
then I create like 1,000 variation of that.
Yeah.
So which still means that now the simulation environment are kind of getting better by taking real data and putting it in.
So what you are objecting to is the pure synthetic approach. You think there's a ping pong match going back and forth here. You do synthetic, and then you upgrade it with some, you validate it back and forth, or you install like the game engine starts with real images, put that, makes 1,000 simulations, and then check that back. So is that what you're saying, that this combination?
Yeah, I think
the purely synthetic, you think is the hard one?
Well, it depends on the problem. If you just need to do, for example, just text, okay, then maybe we can already find an understanding. Like, sure, you can probably generate with a very good LLM and maybe like text which resemble, like you can have, but then still that will be simulated text that comes from another AI trained on real text. So you will still have this need that you cannot get rid of, which is the real stuff. To go purely like train an AI without any real data, I don't see it happening today.
Agreed, not today, but I think there could be a reason for that. Potentially, if we have an AlphaZero moment for foundational models, we've certainly not seen it yet, but I think it could happen.
I want to humor Anders a little bit. So we are talking now about different ways where we need to go in order to get to more and more general AI and intelligence. So the other dimension that you want to talk about is, you call it the latent space. I saw another paper talking about this as a concept space or concept.
Yeah,
is that the same?
No, it's not the same, but it's getting closer to it at least. So
it
was a meta paper, I think.
The meta paper was the concept.
Yeah, so it's basically going to a sentence instead of a token.
Yeah, but then
one layer from the end token.
But I think once again the computer vision, the computer vision example was, of course, going from pixels to concepts. Like this is concepts like animals. From concepts of animals, these are four-legged animals, and these are now cats. Yeah. And this is not the same as latent space.
It's moving in that direction, but just a very, very small step. It's not the JEPA approach yet, it is in that direction.
But
you read the JEPA?
What is it? Joint embedding predictive architecture, prediction architecture. Yeah. And no, that's very fascinating. Like I think that's also what we're saying. What we're saying, right? That you cannot have a single element in your AI pipeline doing all the work. You need this word. Like I think in JPA you have these word models, and then you have the configurator, the perception module, and there all this collaboration that you have with them. Yeah, so I think we're definitely. I mean, I see it like right now, even in our work.
It resonates with you.
Yeah, definitely. I mean, even in our work that we do in the field of domain adaptation, we already introduce. Most of our work have a component called observer and another component called the orchestrator, that effectively are these two components, like understanding if you change the domain, how this change look like, giving a semantic meaning to that, and then orchestrate either the training time, learning process, or maybe orchestrate which model to pick from your library and then fusing them.
So then you are, and you could even argue the mixture of experts approach here, or is that different, or is that actually Is it different ways of describing the same thing? Or is it actually different?
I think it's different, but still, it will be exciting times, and
But do you please, you. But I was thinking about the JEP. I was thinking about the latent space idea.
Let's take one approach, but I think I speak too much. So, but okay, let's me take one theory and see what you think about it. Right. So, we know, of course, you're interested in multimodal kind of approaches, and then today we have large text models or large language models that, of course, are operating and doing predictions in the token space. I think also we know that the first layers of any kind of GPT kind of model is also then just encoding from the syntactic to some kind of semantic representation, then a lot of layers, and then some kind of decoding happening in the final layers, going from some kind of semantic representation or some latent space back into some token space.
Yes.
Right?
Yes.
And then you could think, just from an efficiency point of view, it's kind of stupid if you just want to generate a number of tokens to go back and forth in token space all the time.
Absolutely.
And just, stay in the semantic space and latent space and just do the predictions there, right?
100%. Yeah.
So that's one thing. The other thing then is that if we want to combine different modalities, and then we know that text has some modality, and then you have images and the patches potentially from them. If you want to do some reasoning combining them, of course you can't operate in sensor space. You need to move into the latent space to do that, and then you can combine both the textual representations and the image representation. So if you want to do multimodal kind of reasoning, you need to be not in sensor space or token space or image space, but in latent space, right?
Absolutely, yeah.
So given all of this, it's much more efficient to move in latent space and do the reasoning that we're seeing O3, O1, R-star math doing. They are still doing reasoning in token space.
Yeah, which is terrible. I mean,
it is terrible,
yes.
Right? So it seems obvious to me, why don't someone start moving into latent space reasoning?
Because it's very complicated. No, but it's absolutely true. Even I always come back to this comparison. Think about diffusion models. So diffusion models are the progressive denoising approach. The early diffusion models, like if you think, what was the name? The one that you use, the one OpenAI, DALL-E. The first one, I think, it was applying, I'm not sure, I don't remember, but I think it was applying diffusion process on the pixel space. And it was pretty bad. Yep. Then stable diffusion was, I think, one of the first papers then saying we don't do the diffusion process on the pixel space. Exactly. We take the image, right?
So all the diffusion models today have an autoencoder basically around it. So you operate in latent space because it's too
so we even have a pattern here.
Yeah. So that's the thing. When you do, and as I see it, I see chain of thought, just a rudimental. I mean, of course, mathematically they're not the same to diffusion, but they are already people applying diffusion to chain of thought to get this bridge.
But this is actually what John LeCun is speaking about in the JEPA model. So they speak about the embedding, joint meaning both the input and the output. So you first, if you want to have some output, you don't predict the output space. You actually predict in the energy space in the middle. Yeah. So that's a joint embedding part. So you go from the sensor to some kind of embedding, the latent space, and then you do the predictions there, and then you have multiple steps. This is literally what he's saying in this paper. And then you have some kind of world model that is trying to see, if you do this prediction, what will the value be from a world point of view in the next state? And then you can judge, should you move in that direction or in that direction? Yeah. This is R-star math, more or less.
Yeah, but what are then the breakthrough? Because you said this is so obvious, we should go here. But why aren't we going here? Oh, it's complicated. So can we break, what are the steps then?
We have to go to the good AI lab and do a paper on this.
Yeah, you need a paper. You could, if you bring this angle in, you can get him on board on this paper for sure.
Yeah. So,
but because it's complicated, we say. But what are the steps to go in this direction that we are not doing then?
No, I mean, not like we're not doing them. I think there are already some chain of thought papers that are not calling it anymore chain of thought. They're more like this iterative refinement or applying energy models or diffusion models to the embedding space. Just the thing is that they're just still very experimental and a bit exotic nowadays. Yeah. But and of course another problem is that you lose a bit of explainability of the thinking process. But I would even claim that maybe you don't really care anymore about that explainability. I mean, the thing is like, what is the cost of this explainability? Yeah. If the cost is a worse model, then I personally am okay with lower explainability.
It depends on the use case, as always. Yeah.
Or that's the same. And the same when we have autonomous driving, right? Yeah. A simple, explainable pipeline or an efficient pipeline.
Exactly.
So. No, but I agree that we need to get rid of English within the model, right? They cannot reason in English. Doesn't make sense. We as humans, we don't reason in English or in any language. So, or maybe sometimes we do, but it's more like right. It's not a fully formed English, or if it is, it's just some of our thoughts are
some abstract version.
Yeah.
Oh, Pierre, time is. Oh, Jesus, it's a long. We try to keep it within 2 hours, but we fail.
We fail.
We're actually trying to keep it in 1.5 hours. But now it's 2.5 hours.
And this is kudos to you. And this is just this is.
And we've been stopping the one rabbit hole after the other.
Yeah, and there's so many left. There's so many left.
Pierre, one final question then.
All right.
If we assume that there will be some kind of AGI, and we can think about what AGI means, etc., but don't care about that, right? Assume at some point we will have an AGI that is better than most humans at an average task or whatever. If that becomes a reality, we can think about two extremes here and a spectrum in between, but some extreme. One extreme would be that we have a dystopian like the Matrix and the Terminators, and the machines will kill us all.
Okay.
And when we lose control, because at some point we probably lose control of the AI in some way. And the other extreme would be that it becomes this kind of utopian world where we live in the world of abundance, as Elon called it, where the price of goods and services will go to zero, and we basically will have not only universal basic income, as he called it, but actually universal high income, because we can live in luxury more or less compared to today, because it's so we have like free energy, we have free housing, we have solved cancer, we have fixed the energy problem, we have fixed the climate change and whatever, and we start to live in some kind of utopia. Where do you think we will end up in, let's say, 10 years? Is it going towards more the utopian or more dystopian kind of future?
I think both views are somewhat, I see quite equally unrealistic, to be honest. I think what it's gonna really happen is that as every other technology, as we develop it further, the real risk is that we will increase further social inequalities.
Yes.
So both of the two things.
Concentration of power, right? Because that's literally what we're seeing today in an extreme, I would say.
And maybe you can even say that these two things will happen at the same time. So there will be some part of the world that will benefit.
This is Sverker Jansson's comment from Rice. We will have both.
Yeah, I think then I agree. I agree with that. There will be part of the world where, of course, a lot of problems will be solved, but then at what cost? And then I don't think in any way that this will be a democratic process, or that. I mean, we've seen how the world is it today, and I don't think it's gonna
change the fundamentals.
Yeah, change the fundamental of it. It's gonna just make it more extreme in this sense, and that's also actually something that. Connect. I mean, this thought is also about the foundation of the good AI lab.
Yeah, I was just going to see that, because one of the reasons we started to talk about the AI divide. We talked about consistently the AI divide for 5 years, and it has always proven that the social inequalities, the haves and who haves nots, has always been a problem, and it ultimately leads to war, it leads to revolution. So if that happens in AI. So maybe that also puts a finger on, why you have the good AI lab, and how we should write our own future, and maybe one of the key objective functions on a macro and geopolitical level is inclusivity, or take away the AI inequalities, and that's maybe one of the key objectives we need to work on.
Yeah, and one thing that I've been saying for a long time is not really that it's the problem where AI will take control. Actually, I'm longing for that time. I feel more safe at that time. What I'm really scared about is short term. And what we're seeing right now is that AI will create a lot of power to the people or the company that have the best of it. And we literally see that and seen that for a number of years with the hyperscalers, and now with some Elon companies. And if that concentration of power will continue to increase, that's super scary to me. And this is the short-term kind of, and then of course the whole warfare kind of angle is super scary and everything. But this is the short-term danger, not really when AGI take control, but when people are getting increasingly, higher power, and the disconnect between the rest of the world. That's super scary to me.
Yeah, but to me then, and to end on this note, so we could argue about, as we had before, do we need to have a closed or open source models? And then it's one evil or one cost over the other. So if you go the frontier model, that might drive and more extreme distribution of power or like inequalities. And then you have that problem to deal with. And if you go open source, you are doing that because your main objective function is equality. Yeah. But then you have other risks with that. And which risk is worse, So I could argue, if you look at this on not geopolitical perspective, but a societal, sustainable Earth perspective, which one trumps the other is a tricky trade-off. Yeah.
Well, yeah, I mean, to me, it's not that tricky. I have a very candid, I'm very candid about that. I think the justifications for not going open source are really coming from,
greed.
The
power,
profit, and economical creating these entry barriers for
the risks
others.
of the risks that are upplayed from the frontier model. You are thinking about that as a narrative for the people in power, and where you really say AI for all. That's AI for good is AI for all.
Well, I'm not saying no. I would say the good AI lab has its own. That's a different story. We are not discussing about AGI.
No, that was your input.
But yeah, but my personal opinion when it comes to it is more that I think the development of AI, it's not about AI. How can I put this? The thing I'm not afraid either about when the AGI will take control. Even though, because as we move into it, we are understanding that AGI. What is even AGI? It's kind of this.
We will pass it and look
apart.
back at it and try to put the number on it. When did we pass it?
we are already seeing that it's kind of a spectrum of it, yes. Right? So it's not a single breakthrough.
Level 1 to 5.
We reach it, and So I truly believe that it's gonna be better for the people who are privileged, but I don't see it getting better for everyone, and that's what.
And this is what we should really work on as a community and as an industry. To work on it becoming better or inclusive for everyone is maybe one of the key objectives.
I think so.
Okay, I'd like to end it there.
Perfect. That's perfect ending note. Thank you so much, Pier, for coming here. This was an amazing discussion. I hope you can stay on for a bit longer after the camera turns off, and going to speak about so many more interesting topics.
All right.
Thank you so much for coming.
Thank you so much, Pier.
Thank you.